In the summer of 2019, astronomers spotted something weird slicing through the solar system. A glowing blur that wasn't from around here. It wasn't an asteroid. It wasn't a spacecraft. It was a comet, but not one of ours. Named Borisov, after the amateur astronomer who first saw it, this icy traveler came from another star system, making it the first confirmed interstellar comet to ever crash the solar system's party. If space had a "you're not from around here, are you?" moment, this was it. Good evening, curious minds. Science doesn't need to shout to be fascinating. Sometimes, it's best enjoyed the way you'd enjoy a late-night conversation. Quietly, with a cup of tea, and maybe the soft hum of a fan in the background. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing. No pressure. Only if you enjoy these calm journeys through the universe. Now, let's begin. At first, nobody was quite sure what they were looking at. The night sky is full of moving dots, asteroids, satellites, the occasional lost screw from a rocket launch. But this one moved differently. It didn't seem to care about the rules. It wasn't looping around the sun like a good, obedient comet should. It was cutting straight through, like it had a plane to catch and no time for cosmic sightseeing. Astronomers are used to tracking regular visitors, the ones born in the cold outer edges of our own solar system. But this one had the swagger of someone who'd traveled light years just to make a brief cameo. To appreciate how weird this is, you have to understand that comets are the homebodies of space. They form alongside their star, spend billions of years orbiting it, and occasionally swing by the inner system to say hello, leaving trails of dust that give us meteor showers. But Borisov broke the mold. It was like finding a snowball that had somehow rolled in from another neighborhood. One so far away you couldn't even see its porch light. Its path through our solar system was unmistakably alien. Not just a strange orbit, but a trajectory that screamed visitor, not resident. For astronomers, this was both thrilling and confusing. We've always imagined our solar system as a closed stage, with all the actors already cast: planets, moons, asteroids, and comets that all share the same director: the sun. But Borisov was the uninvited guest who kicked the door open mid-performance. And instead of security escorting it out, every telescope on Earth turned to stare. After all, this was history in motion, a piece of another world drifting right past ours. The moment the discovery was confirmed, the scientific world collectively gasped. It was the first time we had proof that icy leftovers from other stars could wander into our domain. Before Borisov, there was speculation that interstellar comets might exist, but seeing one was a different story. It's a bit like talking about unicorns your whole life, and then one trots into your backyard, munching your lawn. You could say Borisov's arrival was a reminder of how small our solar system really is. For all our planetary pride, we're just one neighborhood in a sprawling galactic city. Every so often, someone from across town passes by, and Borisov was that someone. Its journey likely began billions of years ago, flung out of its home system by the gravitational chaos of forming planets. Maybe a giant world kicked it loose, like a cosmic bouncer tossing out an icy troublemaker. It's been wandering through the dark ever since, frozen solid, carrying the chemical fingerprint of a place humanity will probably never see. When you picture Borisov, imagine a nucleus of dirty ice and rock a few 100 meters across. Nothing spectacular at first glance. But what made it extraordinary was what it represented. A messenger from the beyond, carrying clues about the chemistry of other suns. Its very presence told us that comets aren't unique to our solar system. The universe, it seems, loves to make snowballs. Of course, nature didn't attach a made in another galaxy tag to it, so scientists had to piece together the clues. Its speed was the first giveaway. It was moving far too fast to be bound by the sun's gravity. Even when the sun tried its best to pull Borisov into orbit, the comet simply shrugged and kept going. This wasn't a tourist, it was a drifter destined never to return. You might think, okay, so it's just a comet on a weird path. But here's the thing. Discoveries like Borisov force us to rewrite parts of astronomy textbooks. We'd theorized for decades that comets might escape their systems. But spotting one was a cosmic lottery win. It was proof that material from other solar systems doesn't just exist. It travels. And when it does, it sometimes passes close enough for us to study. The moment you realize that, your perspective shifts. Space stops being an empty void and starts looking like a galactic highway, full of drifting objects, each carrying stories of their origins. Somewhere out there, countless Borisovs are wandering between stars, silent witnesses to the births and deaths of worlds. We just got lucky enough to meet one. As it streaked through the solar system, Borisov became an instant celebrity. Telescopes around the world followed it, every observatory wanting a glimpse before it faded back into the dark. And, while its visit was brief, its message was clear. The boundaries between star systems aren't walls. They're wide-open spaces, and sometimes travelers cross them. So, in a universe that often feels unimaginably vast and impersonal, Borisov's fleeting appearance was oddly comforting. It was a cosmic wave from a stranger saying, "Hey, you're not alone out here." And just as suddenly as it came, it was gone. An icy drifter vanishing into the black, leaving us staring at the sky, wondering how many more visitors might be out there, waiting for their turn to pass through the light of our sun. Gennadiy Borisov, using a telescope he built himself, noticed a faint streak moving oddly fast across the sky. Unlike local comets, Borisov wasn't orbiting the sun. It was blasting straight through like it had somewhere else to be. That was the first clue it wasn't native. It's as if someone at a family reunion realized one cousin had the wrong surname and a completely different accent. In a world dominated by billion-dollar space telescopes and government-funded observatories, it's poetic that this groundbreaking discovery came from one man tinkering in his garage in Crimea. Gennadiy Borisov wasn't a NASA engineer or a tenured astrophysicist. He was an engineer and an amateur astronomer with an obsession for the night sky and a habit of building his own telescopes from scratch. It's the astronomical equivalent of someone discovering a new species using binoculars made out of recycled soda bottles. He had no massive research team, no high-end observatory, just skill, patience, and a love for celestial puzzles. On August 30th, 2019, he noticed something odd while scanning the sky with his homemade telescope, an instrument that looked like a Frankenstein's monster of glass, metal, and pure determination. Through the eyepiece, He saw a faint blur of light moving just a little too quickly for comfort. Most comets drift lazily across the field of view, their motion barely noticeable. But this one, it was sprinting. It was as if it knew it was being watched and decided to make a break for it. Borisov did what any good scientist, or in this case, science-obsessed engineer, would do. He double-checked. He spent hours measuring, recalibrating, and staring until his eyes probably felt like burnt marshmallows. But the numbers didn't lie. The object's speed and trajectory were off the charts for a local comet. So he reported his observation to the Minor Planet Center, the global hotline for, "Hey, I think I found something in space." Within hours, observatories around the world started turning their telescopes toward the coordinates he'd provided, and when they did, jaws collectively dropped. The initial images came back showing a fuzzy object with a distinct tail, a dead giveaway that it was a comet, but something didn't fit. Its path through the sky was far steeper and faster than anything expected from a solar system body. It wasn't curving gently toward the sun, it was barreling through the ecliptic plane like a cosmic spear. Within days, astronomers began running orbital calculations, and the result was astonishing. The comet's trajectory was hyperbolic. That meant it wasn't bound by the sun's gravity. It wasn't visiting, it was passing through. Now, let's pause here for a second. To most of us, the phrase hyperbolic orbit sounds like something you'd hear in a sci-fi movie right before the spaceship explodes. But in astronomy, it's the smoking gun that an object is interstellar. Most comets have elliptical orbits. They swing out to the edges of the solar system, then back again in loops that can take hundreds or thousands of years. A hyperbolic orbit, on the other hand, means it's not coming back, ever. The sun can tug at it, slow it down a bit, but ultimately, it'll just keep going, free as a bird with zero intention of settling down. As more observatories confirmed the data, the scientific community went from skeptical murmurs to full-blown excitement. An interstellar comet, the first one ever seen. And discovered not by some government agency or a massive telescope array, but by a quiet, determined amateur astronomer working alone. There's something deeply human about that, a reminder that curiosity still matters, even in the age of automation and billion-dollar satellites. Imagine Gennadiy Borisov on that night, standing under the dark Crimean sky, surrounded by the hum of crickets and the quiet whisper of the wind, completely unaware that he was about to etch his name into scientific history. Somewhere between adjusting knobs and jotting down coordinates, he caught a glimpse of something that had traveled for possibly millions of years across interstellar space just to momentarily pass through his field of view. That's the kind of poetic timing the universe seems to specialize in. Once word spread, the hunt for more data became a global frenzy. Observatories from Chile to Hawaii scrambled to collect images, while astronomers fired up computers to model its motion. Every observation confirmed the same thing. Borisov's comet wasn't from around here. And with that confirmation, the comet officially earned its name, 2I or Borisov, the 2I meaning second interstellar object, following the earlier discovery of Oumuamua. But while Oumuamua was mysterious and rock-like, Borisov was a full-blown comet, complete with tail and coma, a proper, photogenic alien visitor. news outlets went wild. Headlines read like something out of science fiction. Alien comet spotted in our solar system. For once, they weren't exaggerating. And while most of the world saw it as just another space oddity, for scientists, it was a dream come true. Borisov wasn't just an object. It was evidence that other planetary systems create comets too, that the same physical processes shaping our solar system happen elsewhere across the galaxy. It was a cosmic reminder that our sun is just one kitchen in a galaxy-wide bakery of star systems cooking up icy leftovers. And as for Gennadiy Borisov, he suddenly became the most famous amateur astronomer on Earth. His discovery showed that passion and persistence could still rival technology and funding. Somewhere, a NASA scientist probably sighed and said, "Great, now we all look bad." The story of Borisov's discovery isn't just about an icy wanderer. It's about human wonder. About the fact that one person, looking through a handmade telescope, could spot something born around another star. It's a story of how curiosity transcends budgets, titles, and borders. Because sometimes, all it takes to shake the sky is one person willing to look a little closer and notice that one of the stars doesn't quite belong. For an object to be interstellar, it must not be gravitationally bound to our sun. It just passes by, tipping its hat on the way through. Borisov's path was hyperbolic, meaning it was on a one-way trip through the neighborhood. Most comets loop around like boomerangs. Borisov was a cosmic bullet. If space had speed limits, this comet would have collected a dozen tickets. When astronomers talk about interstellar visitors, they don't mean objects that came from the edge of the solar system. They mean outsiders. True strangers. To qualify, something has to enter the solar system from beyond the sun's gravitational influence, swing through our neighborhood once, and then keep on going forever. It's like the celestial equivalent of someone walking into a cafe, ordering a coffee, and walking straight out the back door without stopping for small talk. The key word here is bound. Most of the objects in our solar system, planets, moons, asteroids, and comets, are bound to the sun's gravity. Even if their orbits are long and stretched, they still come back eventually. Think of gravity as an invisible leash. The sun holds everything in, whether it's Mercury doing a tight lap in just 88 days or faraway comets taking thousands of years to return from the Oort cloud. But a hyperbolic orbit. That's a leash snapped clean off. Borisov's trajectory was the astronomical smoking gun. When scientists plotted its path through the solar system, the curve wasn't an ellipse or even an elongated oval. It was open, shaped like a wide, unending arc. That open curve meant one thing. The sun could tug all it wanted, but Borisov wasn't coming back. It had too much kinetic energy to ever be captured. It entered fast, looped by, and left faster, like the universe's version of a drive-by hello. How fast are we talking? At its closest approach to the sun, Borisov was moving at around 170,000 kilometers per hour. That's about 47 kilometers per second. To put that in perspective, if Borisov had flown past Earth at that speed, it would have circled the planet in less than 9 minutes. For comparison, even our fastest spacecraft, like NASA's Parker Solar Probe, crawl in slow motion next to that. The comet was a runaway snowball from the stars, cruising at a speed that screamed, "I don't belong here." Now, speed alone doesn't make something interstellar. There are asteroids that move quickly too, but the combination of that speed and the shape of Borisov's orbit told astronomers the full story. You can think of it like cosmic fingerprinting. Every orbit leaves a signature that reveals whether something was born under the sun's influence or just passing through. Borisov's orbital eccentricity, the measure of how stretched an orbit is, was greater than 1. Anything above 1 is an open curve, meaning an escapee. For Borisov, that number wasn't just slightly above 1, it was way past it, confirming without a doubt that it hailed from beyond the solar system. To appreciate how rare this is, imagine a comet being tossed out of its home star system millions or even billions of years ago. During the early stages of planet formation, newborn stars are chaotic places. Planets collide, asteroids crash, and comets get slingshotted around like pinballs. Every so often, one gets too close to a massive planet and gets flung into deep space. That's probably how Borisov began its journey, banished from its home system by a gravitational accident. It's been traveling ever since, drifting between stars in the cold void, carrying frozen clues about its birthplace. For countless millennia, Borisov wandered through interstellar space, a region so empty it makes the vacuum of space inside our solar system look crowded. Out there, temperatures drop close to absolute zero. There's no sunlight, no warmth, no radiation from a nearby star. Just a black ocean of nothingness. Borisov endured all of it, untouched and unchanged, until fate and orbital geometry aligned to send it skimming through our cosmic front yard. The odds of that happening are mind-bogglingly small, which is why the discovery sent such ripples through the astronomy world. When you think about what it means for something to be interstellar, it's not just about the path it takes, it's about the story it carries. Borisov wasn't built from the same dust and gas that made Earth, or the Sun, or any of our comets. It was made under a different star. Maybe with a slightly different chemical mix, a different radiation environment, perhaps even around a binary system. Every atom of ice and dust inside it was a time capsule from another corner of the galaxy. Studying it is like finding a bottle floating in an ocean, except the message inside is written in chemistry. To confirm all of this, scientists had to be meticulous. They measured its velocity as it approached, how much it slowed as it passed near the sun, and how its trajectory changed as it exited. If Borisov had been a normal comet, the sun's gravity would have pulled it into an elongated orbit, keeping it tethered. But even after the sun gave it a strong tug, Borisov's path barely bent. It was on what astronomers call an escape trajectory. Once it leaves the sun's gravitational reach entirely, it will keep going indefinitely, destined to roam the galaxy long after the last human telescope has gone dark. There's something beautifully humbling about that. Borisov doesn't belong to any one solar system. It belongs to the galaxy itself. It's a citizen of nowhere and everywhere at once, and while it might sound lonely, there's poetry in that too. Every now and then, as it glides past another star system in a few million years, maybe it'll catch a glimmer of light from another curious civilization pointing their telescopes upward, and they'll see what we saw, a mysterious visitor streaking across their sky, bound to no sun, loyal to no home. In that sense, what makes Borisov interstellar isn't just its orbit. It's its spirit. It's the embodiment of cosmic independence, a frozen traveler that refuses to stay still. It's proof that the universe is full of wanderers, and that sometimes, even across the emptiest expanses of space, paths can cross in the most extraordinary ways. Borisov's orbit suggested it came from far beyond the Oort cloud, possibly ejected from another solar system billions of years ago. Imagine being kicked out of your home star's backyard and drifting through deep space for eons, only to randomly stumble into ours. It's like showing up at a stranger's barbecue after a century-long walk just to say hi. When astronomers traced Borisov's path backward, the numbers told a remarkable story. Its trajectory didn't just skim past the outer edges of our solar system. It came from a direction and velocity that ruled out any possible local origin. If you were to draw it a path on a cosmic map, it would trace a long, elegant curve that stretches straight through the borders of our sun's domain and deep into the endless galactic wilderness. It hadn't come from the Oort cloud, that vast shell of icy debris surrounding the solar system. It came from beyond even that, a region where the sun's gravity gives up and the Milky Way takes over. To put this in perspective, the Oort cloud is thought to begin about 300 billion kilometers from the sun and might extend out to nearly 30 trillion kilometers. That's so far that sunlight takes a year to get there. Beyond that, there's no edge in the traditional sense, just open space, full of invisible wanderers drifting between the stars. And one of them, one lonely fragment of ice and dust, just happened to wander into our view. The sheer randomness of it is staggering. The galaxy is roughly 100,000 light-years wide, yet a rock less than a kilometer across happened to pass within telescope range of a small planet orbiting one very average star. That's like tossing a grain of sand across the Pacific Ocean and hitting a seashell by accident. But how does a comet even end up in interstellar space to begin with? To answer that, you have to rewind the cosmic clock all the way to a comet's birthplace. In the early days of a star system, when planets are still forming out of dust and gas, everything is chaos. Young planets tug on smaller bodies, flinging them around like cosmic dodgeballs. Some get pulled inward, crashing into planets or their stars. Others are launched outward, gaining just enough speed to escape the gravitational pull of their home system entirely. Once that happens, there's no coming back. They're cast adrift, doomed to wander the interstellar void. That's likely what happened to Borisov. Billions of years ago, in a star system far, far away, a young gas giant, maybe a Jupiter-like planet, gave it a gravitational shove powerful enough to send it flying out of its home orbit forever. Over time, it drifted away from the warmth of its sun, through the dim outskirts of its system, and into the deep freeze of interstellar space. Out there, time stretches in ways that are hard to imagine. For billions of years, Borisov floated alone, untouched, slowly tumbling through the dark. Every surface molecule frozen solid, every atom holding the memory of the star it once orbited. If you could have followed Borisov's journey, you would have seen nothing for ages, just an endless night, punctuated by the faintest glows of distant stars. Occasionally, It might have passed within a few light years of another system, but not close enough to be caught. Gravity in space is a subtle thing. Most of the time, these wanderers keep right on going, like marathon runners who never stop for water. Borisov, in that sense, was a veteran traveler. By the time it reached us, it had likely spent longer in interstellar space than Earth itself has existed. When scientists realized that, they started to think of Borisov not just as a comet, but as a messenger. Every comet in our solar system tells the story of how our planets formed, what materials were present, what conditions existed. But Borisov carried a completely different passport. Its ice, dust, and carbon compounds weren't shaped by our sun. They were forged in a foreign disk of gas and rock that once circled another star. It was the closest thing to holding a sample from another solar system without ever leaving home. Astronomers love to compare data, and Borisov gave them a rare opportunity to do just that. By analyzing the way it reflected sunlight, they could compare its composition to that of local comets. Surprisingly, Borisov didn't look alien in a sci-fi sense. It looked familiar. That meant other solar systems probably go through the same processes ours did when forming comets. It's like meeting someone from across the galaxy and realizing you both make coffee the same way. Different kitchens, same recipe. That discovery alone reshaped how scientists think about the universality of planet formation. But beyond the data and numbers, there's something profoundly humbling about what Borisov's path implies. This wasn't just a rock wandering aimlessly. It was a survivor of cosmic violence, a relic from a place humanity will likely never see. It's the definition of ancient, older than any fossil, any mountain, any ocean on Earth. If you could touch it, you'd be touching something that has literally seen stars come and go. Its orbit, when plotted against the galactic background, points roughly in the direction of the constellation Cassiopeia. That doesn't necessarily mean it came from there. It's just the direction it happened to be traveling when it crossed paths with us. But imagining its home system somewhere among those stars, it adds a romantic dimension to the story. Somewhere in that patch of sky, billions of years ago, a young sun lost one of its comets, and by sheer luck, we became the next stop on its never-ending tour. There's also a touch of melancholy in that thought. Borisov will never go home. Once it leaves our solar system, it'll keep drifting, maybe for another few billion years, until it passes near some other star. Maybe that star will have its own planets, and maybe, just maybe, another civilization will notice a faint blur of light slicing through their skies, and they'll name it after their own version of Borisov. The universe has a way of echoing its stories. So in the end, calling it a cosmic passport feels fitting. Borisov isn't just a traveler, it's a stamped relic of another world, a tiny frozen time capsule with credentials written in ice and dust. It's proof that the galaxy is interconnected, that no solar system is truly isolated. Every now and then, something crosses the invisible borders, reminding us that space isn't a series of separate islands, but one vast, restless ocean. And in that ocean, every traveler, no matter how small or distant, carries a story of where it's been, and where it might go next. Unlike fictional aliens, Borisov wasn't green or chatty, but it was extraterrestrial in the truest sense. Its composition hinted that other star systems make comets remarkably similar to ours. That's both comforting and eerie. Space chemistry seems to have a universal recipe book. Somewhere out there, another sun might be stirring the same cosmic soup. When Borisov entered our solar system, scientists had no idea what kind of chemical secrets it was carrying. Here was a visitor that didn't come from our sun's nursery, a time capsule from another star system entirely. If ever there was a chance to test whether the universe plays by the same rules everywhere, this was it. And the results were both surprising and oddly familiar. Astronomers quickly turned every available telescope toward it. The Hubble Space Telescope watched from above Earth's atmosphere, while observatories from Chile to Hawaii tracked its glowing tail. They measured the sunlight bouncing off the dust and gas around it, using a technique called spectroscopy, the science of turning light into information. When you break down light from an object, you can see distinct patterns of absorption and emission, like fingerprints. Those patterns tell you what elements and molecules are present. For Borisov, those fingerprints revealed a chemistry that could have come straight out of our own backyard. It had water vapor, carbon monoxide, cyanide, and a dust. Ingredients that sound like a recipe for disaster, but are, in cosmic terms, totally ordinary. These are the same substances found in comets born around our sun. The resemblance was uncanny. If you didn't know better, you'd think Borisov was a local comet just doing its rounds. This was not some exotic, alien brew of mysterious chemicals. It was the same familiar mix of frozen volatiles and dusty grains we've seen 1,000 times before. That realization blew scientists' minds. It meant that whatever star system Borisov came from followed similar chemical rules when it formed. Despite being born under a completely different sun, in a different corner of the galaxy, it was made of the same stuff. That's a profound thought. It suggests that the building blocks of planets, comets, and maybe even life itself aren't unique to our solar system. They're everywhere. The cosmos isn't a chaotic mess of unique recipes. It's a shared kitchen with a universal menu. Hydrogen, oxygen, carbon, and nitrogen, the four horsemen of chemistry, seem to conspire again and again to make the same kinds of cosmic leftovers. But there were subtle differences. Borisov contained unusually high amounts of carbon monoxide, far more than most local comets. Carbon monoxide forms in extreme cold, the kind of deep freeze that exists far from any star's warmth. That told scientists that Borisov had probably formed much farther from its sun than most of our comets did. It might have been born in the outermost reaches of its system, where light was a rumor and temperatures stayed colder than the surface of Pluto. In a way, Borisov was a child of darkness, an icy wanderer forged in a frozen frontier. This difference gave scientists a clue about the diversity of planetary systems out there. Even though Borisov's recipe matched ours in broad strokes, the proportions were tweaked, like someone using a little extra salt in a universal dish. It suggested that while the universe follows the same chemistry set, each star system has its own flavor. It's as if every solar system is a different version of the hype song, played in a different key. To study these differences, scientists observed how Borisov's ices sublimated. That's when a solid turns directly into gas as sunlight warms it. By measuring how quickly different molecules evaporated, Astronomers could reconstruct what Borisov was made of layer by layer. They found that its ices were unusually pristine. Unlike comets from our solar system, which have spent millions of years getting scorched and reshaped by sunlight, Borisov was untouched. It had never been close to a star before. Every molecule was original, unaltered since the day it formed. It was a fossil from another world, preserved in cosmic deep freeze. That's what made it such a scientific treasure. Studying Borisov wasn't just about understanding one comet. It was about glimpsing the early chemistry of another solar system. It was a chance to peek into a process that happened light years away and billions of years ago. And remarkably, it told us that our solar system isn't special. It's typical. The processes that shaped our planets and comets are happening all over the galaxy, probably producing countless worlds built from the same materials. There's something strangely comforting about that thought. It means the conditions that led to life here might not be rare at all. If other suns are forming comets like Borisov, rich in water and carbon compounds, then they're also spreading those same ingredients across their systems. Comets are nature's delivery trucks, scattering water and organics to rocky planets. Maybe, somewhere out there, another planet has its own oceans, because a comet like Borisov delivered the goods. Still, there's an eerie side to it too. Because if space really is working from one universal recipe, then the galaxy might be full of versions of us, planets that look like Earth with clouds, oceans, and maybe even life. We're not talking little green men waving antennas, but microbes, plants, or creatures evolving under alien skies, all thanks to the same chemistry that built Borisov and our own comets. The thought that we might not be unique is both exhilarating and unsettling. As Borisov passed through the solar system, scientists couldn't help but imagine its long journey ahead. Once it left, it would carry those same elements back into the galactic sea, untouched, unchanged, and ready to drift for another billion years. Somewhere far in the future, it might pass close to another star, warming again, releasing those same vapors, hydrogen, oxygen, carbon, nitrogen, into a new system, starting the cycle over. That's the quiet magic of Borisov. It wasn't flashy or loud, but it carried a message older than our sun. The galaxy is connected through chemistry. Every comet, planet, and person shares the same ingredients, cooked in different kitchens but from the same cosmic pantry. It's a humbling reminder that no matter how vast the universe feels, we're all part of one grand, ongoing experiment. One where the recipe never changes, only the hands that stir it. Telescopes worldwide turned their eyes toward Borisov. Observatories scrambled like paparazzi trying to get the best shot before it vanished. Hubble caught glimpses of a dusty tail stretching hundreds of thousands of kilometers. For scientists, this was the universe's version of a celebrity cameo. Blink, and you'd miss it. Once the confirmation came that Borisov was truly interstellar, the astronomical world entered a kind of controlled panic. Observatories from every continent were suddenly booked solid. Time on telescopes, normally scheduled months or years in advance, was urgently rearranged. Astronomers who had been planning to study distant galaxies or exoplanets suddenly found themselves competing for a piece of Borisov. The universe had dropped a once-in-a-lifetime guest into our skies, and nobody wanted to miss the interview. But here was the challenge. Borisov wasn't hanging around. It was moving so fast that its position in the sky changed noticeably from night to night. Observing it was like trying to photograph a race car through a straw while standing on a moving platform. Earth was spinning, the comet was moving, and the clock was ticking. Even the largest telescopes had to act quickly before Borisov faded into the cosmic dark again. Teams all over the world coordinated their efforts. Observatories in Chile, Spain, Hawaii, and South Africa each took turns tracking it as it crossed the night sky. Astronomers joked that Borisov was like a galactic rock star on tour, and they were the roadies scrambling to keep up with the schedule. Each night they shared data in real time, passing observations across time zones like an intercontinental relay race. It was one of those rare moments when science felt thrillingly alive, collaborative, competitive, and urgent all at once. The Hubble Space Telescope joined the chase as well. From its perch above Earth's atmosphere, Hubble had an unobstructed view, free from the distortions of air and weather. The images it captured were breathtaking. A tiny, glowing core surrounded by a soft halo of gas, trailing an elegant tail of dust that stretched for hundreds of thousands of kilometers. It was as if the comet were signing its autograph across the stars. For those who saw it through a telescope, Borisov looked deceptively simple, a faint smudge of light with a hint of motion. But behind that smudge was an interstellar detective story unfolding in real time. By measuring the brightness of the coma and tail, scientists could infer how much gas and dust the comet was shedding. Those numbers revealed how sunlight was heating its surface and what kind of materials were evaporating. Every flicker of light was a clue, every spectral reading a new paragraph in Borisov's biography. As Borisov approached the sun, its tail grew longer and brighter, a beautiful consequence of physics in action. When sunlight hits the icy surface of a comet, it heats it just enough for the ice to vaporize, creating a stream of gas that drags dust along with it. Radiation pressure from the sun then blows that material outward, forming the comet's iconic tail. For Borisov, this process unfolded on a grand scale, but with a twist. It had likely never experienced this before. This was its first, and probably only, close encounter with a star. It was a frozen alien, waking up for the first time in billions of years, suddenly sizzling under a sun it had never seen. That realization fascinated astronomers. Watching Borisov heat up was like witnessing a lab experiment with materials older than our solar system. Its ices had never melted before. Its gases had never been released. Every molecule escaping into space was ancient, pristine, and unaltered since the birth of its home system. To scientists, that made it priceless. They were observing chemistry from another world, happening in real time, right before their eyes. But capturing all that data wasn't easy, because Borisov was small, only a few hundred meters across. Its brightness was faint. Even the Hubble telescope had to use long exposures to capture it clearly. Some observatories tracked it for hours, stacking images to tease out details. In those faint patterns of light, they could see the structure of the coma, the grain size of the dust, and even hints of how the nucleus might be rotating. The more they studied it, the more it behaved like a comet that could have come from our own solar system, except for the fact that it was on a one-way ticket out. For amateur astronomers, Borisov was both a dream and a nightmare. It was visible through decent backyard telescopes for a brief window, but its faintness and speed made it difficult to spot. Still, thousands tried, scanning the pre-dawn sky with patience and hope. A few succeeded, snapping grainy but triumphant images. For them, it was the ultimate prize. Proof that they had seen with their own eyes a traveler from another star. It's hard to top that on an astronomy resume. Meanwhile, professional teams worked feverishly to capture every last bit of information before Borisov was gone. They measured the polarization of its light, the composition of its dust, the rate at which its tail expanded. Every new observation was a puzzle piece, revealing more about where it might have come from and what it was made of. Some teams even studied how the tail curved, influenced by the solar wind, a stream of charged particles flowing outward from the sun. By comparing that curve to models, they could estimate the strength of Borisov's gas jets, tiny outbursts of vapor that nudged it through space. And then, as quickly as it had appeared, it began to fade. By early 2020, it was already retreating into the outer solar system, growing dimmer with every passing week. Observatories took their final images like photographers catching the last frame of a setting star. The chase was over, and Borisov slipped back into the black, destined never to return. For scientists, it was both exhilarating and bittersweet. In just a few months, Borisov had given them more than they ever expected. Proof that interstellar comets exist, that their chemistry can be studied, and that humanity can recognize and document them even on fleeting timescales. It had been a cosmic sprint, and everyone knew it. The Great Chase wasn't just about a comet, it was about humanity's reflex to look up, to drop everything the moment the universe sends something new. It showed that even in the era of high technology and planned missions, discovery still thrives on surprise. Borisov came uninvited, stayed briefly, and left the whole world staring skyward, breathless, knowing they'd just witnessed a traveler from another sun blaze through hours before vanishing forever into the night. Spectroscopy showed Borisov contained water, carbon monoxide, and dust, ingredients that sound like a weird space smoothie but are standard comet fare. The surprise? The ratios differed slightly from local comets, hinting it formed in a colder, more distant disk around another star. It was like tasting an alien recipe and realizing it's familiar, but with extra cosmic seasoning. If you've ever wondered what a comet is made of, imagine the dirtiest, coldest snow cone in existence: frozen water, dust, carbon compounds, and a sprinkle of metals, all glued together in a chunk of ancient ice. But Borisov's particular blend wasn't just another frozen rock. It was a time capsule from a completely different solar kitchen, containing ingredients that had never been part of our sun's pantry. And, thanks to spectroscopy, the art of decoding light, astronomers were able to crack open its story without ever touching it. Spectroscopy is one of the quiet heroes of modern astronomy. It works like this. Every element and molecule absorbs and emits light at very specific colors, or wavelengths. When you look at an object through a spectrograph, you don't just see light, you see patterns. It's like scanning a barcode that reveals what the object is made of. Hydrogen leaves one set of stripes, carbon monoxide another, and water vapor another still. With Borisov, telescopes from around the world and even orbiting observatories pointed their instruments at that faint, fuzzy glow and began reading the light as if it were a cosmic novel. And what they found was remarkable. The fingerprints of water vapor, carbon monoxide, cyanide, and dust were all there. Classic comet ingredients. But something about the proportions was off. Borisov had unusually high levels of carbon monoxide compared to water. On Earth, carbon monoxide is something we associate with exhaust fumes and bad ventilation. But in space, it's a sign of deep cold. This ratio told scientists that Borisov formed in an environment far colder and darker than the birthplace of most of our comets. That one clue opened an entire chapter of speculation. In our solar system, comets typically form beyond the orbit of Neptune, in the Kuiper belt or the Oort cloud. It's cold out there, but not that cold. The abundance of carbon monoxide in Borisov's ice suggested it came from even farther out in its original system, perhaps in a disk where temperatures hovered just above absolute zero. In that kind of freezer, even gases that normally stay vaporized in space can freeze solid. Borisov, it seemed, was the product of a system that made our outer solar system look like a tropical resort. This was more than just trivia. It was insight into another world's climate. Every ratio of molecules, every trace of a gas, acts like a thermometer and a fingerprint combined. From those readings, scientists could infer what the early disk of Borisov's home system was like. Maybe it had a fainter star, or one that emitted less ultraviolet radiation. Maybe it had more carbon and less oxygen in its nebular mix. Whatever the specifics, Borisov's chemistry whispered of a birthplace that was quiet, dim, and unimaginably cold. The water vapor in Borisov told another part of the story. As the comet approached the sun, its outer layers began to sublimate, ice turning directly into gas. This released jets of vapor and dust, forming its glowing coma and tail. By measuring the rate of that outgassing, scientists could determine how much water was locked in its nucleus. Surprisingly, Borisov released water in bursts that were smaller and more sporadic than typical solar system comets. That made sense. After all, this was its first ever trip near a star. Its surface wasn't layered or weathered from repeated heating. It was raw, ancient ice cracking and boiling for the first time in billions of years. Each molecule of water escaping from Borisov carried a secret. Those atoms, hydrogen and oxygen, had been forged long before our sun existed, probably inside a long-dead star that exploded and seeded the galaxy with the ingredients for new worlds. When Borisov formed, those elements were trapped inside its icy body, frozen in time. And then, as it neared the sun, they were released again, glowing faintly in the vacuum of space. It's strange to think that in those moments, our telescopes were watching ancient stardust evaporate, a cycle of cosmic recycling happening before our eyes. Even the dust in Borisov told a tale. The particles reflected sunlight in a slightly different way than the dust from most comets we know. The grains appeared smaller and more uniform, as if the processes that built them were more delicate or took place in a calmer environment. This hinted at differences in the turbulence and chemistry of the protoplanetary disk where Borisov was born. In a way, the dust acted like fossils in the rock layers of another world, showing how its parent system evolved long ago. Perhaps the most poetic aspect of all this is how universal yet personal Borisov's story felt. On one hand, it proved that the chemistry of star systems follows the same basic rules everywhere. Hydrogen bonds with oxygen to make water, carbon links up with nitrogen to form organic molecules, and ice clumps together with dust to make comets. On the other hand, it also revealed that every system has its own flavor, its own cosmic fingerprint. The universe, it seems, uses the same ingredients but never the same proportions twice. For scientists, this meant that by studying Borisov's ice, they were studying the diversity of planetary systems across the galaxy. If one icy visitor could tell us this much, imagine what 10 or 20 could reveal. The data from Borisov will likely be analyzed for decades, offering clues not only about where it came from, but about the overall processes that create stars and planets. It's as if Borisov left behind a sample of its home system in light and chemistry, a story carved in ice and written across millions of years. There's something profoundly human about our fascination with it. We've always sought to understand where we come from, and Borisov was a reminder that the materials that built us, water, carbon, oxygen, aren't unique to Earth. They're scattered everywhere, waiting to form new worlds, new oceans, and maybe even new lives. Borisov's ice wasn't just frozen water. It was frozen history, a whisper from another sun saying, "We're not so different, you and I." In the end, that's what made Borisov's chemistry so beautiful. It wasn't strange or terrifying. It was familiar, yet subtly different, like hearing a song you know played in another language. Its ices told a story of unity across the cosmos, that even in the coldest, loneliest corners of space, nature follows the same elegant script. And as that ice boiled away into the void, it reminded us that the universe is writing its story everywhere. Molecule by molecule, comet by comet, one frozen traveler at a time. Borisov zipped past the sun at about 170,000 kilometers per hour. It didn't even slow down for sightseeing. Gravity barely nudged it before it kept heading out toward interstellar space again. Earth's fastest spacecrafts look like snails compared to that cosmic sprint. Speed, in the cosmic sense, is a strange thing. You can't see it, not directly, but you can feel its drama through math and motion. Borisov's pace wasn't just fast, it was absurd and at 170,000 kilometers per hour, or roughly 47 kilometers per second. It was moving so quickly that it would take less than 10 minutes to go from the North Pole to the South Pole. That's not just fast enough to break sound barriers. It's fast enough to break solar system barriers. When Borisov entered our celestial neighborhood, the sun's gravity tried its best to capture it. Normally, anything venturing close enough gets caught in a curved orbit, tugged into a loop like a fly trapped in a spider's web. But Borisov wasn't having it. Its trajectory barely bent. The sun managed to change its direction slightly, but not enough to keep it. Borisov simply used the sun's gravity as a slingshot to change lanes before blasting off toward the void again. It was the interstellar equivalent of rolling through a stop sign at warp speed. To understand how wild that is, think about this. Even the fastest human-made object, NASA's Parker Solar Probe, which is literally designed to dive into the sun's atmosphere, travels at about 700,000 kilometers per hour at its peak. That sounds faster, but Parker is locked in an orbit. It loops around and around, bound by gravity. Borisov wasn't looping. It was leaving. Its velocity was escape velocity, but not from a planet or the sun, from the entire solar system. It didn't need permission to exit. It was already on an eternal road trip across the galaxy. As Borisov raced through, astronomers marveled at how little time they had to observe it. Most comets give you months or even years to study their inbound and outbound journeys. Borisov gave us weeks. Its high speed meant it swept past the sun and back into deep space in what felt like a cosmic blink. By the time telescopes got their best look at it near perihelion, the point where it was closest to the sun, it was already halfway through its farewell. At that moment, Borisov was about 2 astronomical units from the sun, roughly twice the distance between Earth and the sun. That might sound far, but in cometary terms, that's practically an intimate encounter. The sunlight there was strong enough to vaporize some of its icy surface, creating the glowing coma and tail that made it visible. But the sun's heat didn't slow it down in the slightest. It didn't even flinch. It just kept flying, as if the solar system were a brief detour on an endless journey. This speed wasn't an accident. It was destiny, written into Borisov's orbit since the moment it was ejected from its home system. Billions of years ago, when it was flung outward by a gravitational nudge, likely from a massive planet, it picked up a permanent excess of energy. That extra push gave it escape velocity from its parent star, and it's been coasting ever since. No engines, no fuel, just the relentless inertia of Newton's first law. Once set in motion, nothing in the universe was going to stop it. And yet, even at such incredible speed, Borisov wasn't in a hurry in the usual sense. Out in interstellar space, where distances are measured in trillions of kilometers, even a blistering 47 kilometers per second is leisurely. At that pace, it would take tens of thousands of years just to cross from one star's influence to another's. Space is vast beyond comprehension. So, what feels like impossible velocity to us is, to the universe, a calm drift. It's like watching a marathon runner sprint through a stadium that spans light years. Still, for the brief time it spent near our sun, Borisov's speed made it a challenge for scientists. Its motion changed the light we observed from it, a phenomenon known as the Doppler effect. When it was approaching, the light shifted slightly toward the blue end of the spectrum. When it receded, it reddened. Astronomers had to account for that shift precisely to decode its spectral signature. The faster the comet moved, the trickier it became to extract accurate data. Borisov wasn't just hard to track, it was actively outrunning the tools used to study it. This constant motion also affected its appearance. Normally, when comets swing around the sun, their tails curve gracefully as solar wind and radiation pressure bend them. But Borisov's tail was straighter, stretched out like a beam. That was because its sheer velocity made the sunlight's push almost negligible by comparison. It was moving too fast for its tail to be dramatically swept aside. The comet's dust and gas were essentially left trailing directly behind it in a thin, elongated stream. The fact that Borisov could move so fast and still hold together was another marvel. As it neared the sun, the increasing heat and radiation could have shattered it completely. Some comets have disintegrated under far gentler conditions, but Borisov endured most of its passage intact, shedding some dust but surviving long enough to tell its story. It wasn't until much later, as it moved away, that signs of fragmentation began to appear. Perhaps after billions of years of loneliness, even the strongest ice starts to crack. Watching Borisov rush away from the sun was like watching a shooting star in slow motion. One moment it was there, luminous and alive, and then it was gone, fading into the outer dark. Its velocity ensured that it would never be captured again, never to orbit, never to return. The sun gave it a brief nudge, and Borisov gave us a brief show. That was the entirety of their relationship, a cosmic one-night stand measured in astronomical units. And yet, that speed, that defiance, is part of what made Borisov unforgettable. It wasn't a comet that lingered. It was a comet that passed through, unbound and unstoppable, a true nomad of the galaxy. In a universe where everything eventually falls into orbit around something, Borisov reminded us that not all travelers stay. Some are just passing by, wild, uncatchable, and destined to keep moving until the stars themselves fade away. So, if there were cosmic traffic laws, Borisov would have broken every one of them. But maybe that's the point. It didn't come to obey. It came to remind us that motion itself is freedom, and that sometimes the most extraordinary stories belong to the ones who never slow down. As Borisov moved away, astronomers saw it breaking apart, leaving a trail of fragments and dust. Think of it as a comet's dramatic exit. If I'm going out with flair. The breakup gave scientists a peek inside, revealing pristine material that had been frozen since the dawn of its home system. When Borisov began to fade from view, many assumed its brief performance was over. It had blazed past the sun, defied gravity, and was already speeding toward the outer reaches of the solar system. But just when astronomers thought the curtain had fallen, the comet decided to put on one last show. Telescopes began to detect subtle changes in its brightness, tiny fluctuations that hinted something unusual was happening. Borisov wasn't dimming steadily, as a comet should after leaving the sun's warmth. It was flickering. That flickering was the first clue. In the vacuum of space, a comet's brightness can shift for a few reasons: rotational wobbling, uneven outgassing, or fragmentation. But when Borisov's light curve began to stutter unpredictably, astronomers suspected the unthinkable. The interstellar traveler was starting to come apart. Not with a single explosive bang, but in a slow, graceful unspooling. For an object that had survived billions of years adrift in interstellar space, this was its swan song. The first clear signs came from the Hubble Space Telescope and the Gemini Observatory. High-resolution images revealed that Borisov's coma, the glowing cloud of gas and dust surrounding its nucleus, was elongating unnaturally. Instead of a compact core, there appeared to be two bright spots inside, slightly separated. In cosmic terms, that was the cometary equivalent of seeing a snowball split in two mid-flight. Over the following days, the separation widened. Borisov had fractured. But for scientists, that breakup was a gold mine. When a comet splits apart, it exposes layers that have been sealed off since its formation. Unlike the weathered outer crust, which has been repeatedly baked and eroded, the inner material is pristine, a frozen record of the conditions in which the comet was born. For Borisov, that meant revealing the untouched ice of another solar system. Astronomers were, for the first time, peering inside the heart of an alien world's leftovers. The light reflected from the debris gave researchers new data to chew on. The fragments sparkled with fine dust, suggesting the nucleus was surprisingly fragile, held together less by solid rock and more by the gentle cohesion of ices and microscopic grains. That fragility wasn't shocking. Comets are notorious for falling apart, but it was telling. It implied that Borisov's home system, wherever it was, produced comets that formed under extremely delicate conditions. Perhaps it grew slowly, in a calm and cold region of its stellar nursery, where small particles could stick together without violent collisions. The composition of the dust itself was another revelation. Observations from the Atacama Large Millimeter Array, ALMA, picked up faint thermal signals from the dust cloud showing that the grains were rich in carbon-based compounds. These were not exotic alien materials, but organic molecules, complex, carbon-bearing structures similar to those found in our own comets. They're the kinds of molecules that, under the right circumstances, can be ingredients for life. It was one of those subtle but profound confirmations. The chemistry that makes life possible isn't unique to our sun's domain. Even in the debris of a shattered traveler, the universe seemed to whisper, "We all use the same building blocks." For a while, astronomers tracked the two main fragments as they drifted apart. Each one released its own tail of gas and dust, like twin comets in a synchronized performance. The breakup wasn't violent. It was more like a slow unraveling, as sublimating gases pushed the pieces gently away from each other. In space, destruction can be oddly elegant. The smaller fragments continued to glow faintly, carried along by Borisov's original trajectory, scattering a ribbon of dust across millions of kilometers. The process raised fascinating questions. Had the sun's heat been the final straw? Or was the comet already cracked when it arrived, weakened by thermal stresses accumulated over billions of years of temperature swings in interstellar space? Some researchers proposed that volatile gases trapped deep inside the nucleus may have built up pressure as they warmed, eventually causing the comet to split apart from within. Others suggested it was mechanical stress, a result of rotation, or the differential heating of its surface as it tumbled through sunlight. Whatever the cause, it was an ending worthy of its journey, quiet, mysterious, and scientifically priceless. As Borisov's debris cloud drifted outward, it continued to reflect sunlight for months, fading slowly into the background stars. To the naked eye, it was invisible, but to sensitive instruments it was still there, a smear of dust, a fading footprint in the darkness. In time, even that dust would disperse completely, returning to the anonymity of the interstellar medium. In a sense, Borisov had simply gone home, its atoms rejoining the galactic haze that gives birth to new stars and planets. The cycle continues endlessly. There's something poetic about the idea of a comet dying mid-journey. It's easy to think of it as a tragedy, a relic torn apart after surviving unimaginable distances. But for astronomers, Borisov's breakup was a gift. It offered a glimpse into something ancient and unreachable. The dust it left behind told the story of its origins with more honesty than any intact surface ever could. The destruction revealed creation. And beyond the science, there's a deeper beauty to the image of Borisov's final act. After billions of years of solitude, it spent a brief moment under the gaze of an alien civilization, ours, and then dissolved into stardust. If comets could choose their destinies, maybe this one would have preferred it that way. To end its journey surrounded by light, leaving a trail that told its story one last time. Even as Borisov vanished into the dark, it left humanity richer. The data gathered from its fading fragments will be studied for decades, each spectrum and image another piece of the puzzle of how worlds form. In its quiet disintegration, it gave us something permanent, a better understanding of our place in the galaxy. So, yes, Borisov broke apart. But in doing so, it didn't vanish. It became part of the very story it carried. The crumbs it scattered across the void were more than dust. They were the final words of a messenger from another star, written in ice, released in light, and carried forever by the winds of space. 2 years before Borisov, we had met Oumuamua, the first interstellar object, though it looked like a cigar-shaped rock, not a comet. But Oumuamua didn't have a tail or much detail to study. Borisov was a scientist's dream. Finally, an alien visitor that actually looked the part. It's as if the universe followed up its cryptic teaser trailer with a full movie. When Oumuamua first appeared in 2017, it stunned the astronomical community. A small, elongated object hurtling through the solar system at incredible speed, it didn't behave like anything we'd seen before. It wasn't orbiting the sun in a familiar, looping path. It was cutting through on a hyperbolic trajectory, the unmistakable signature of something not from our neighborhood. Like Borisov, it came from the stars. But unlike Borisov, Oumuamua was frustratingly mysterious. It had no glowing coma, no streaming tail, no clear indication that it was shedding gas or dust. It was just a rock, or something like one, slipping silently through the void, offering more questions than answers. To this day, Oumuamua remains one of astronomy's great enigmas. Its shape, for instance, baffled everyone. Based on how its brightness changed as it rotated, it seemed to be either extremely elongated, like a cosmic cigar, or extremely flat, like a pancake tumbling through space. Either way, it was unlike any asteroid or comet we'd ever observed. Some joked that it looked like an alien probe. Others, with a bit more restraint, suggested it might be a fragment from a shattered planet or a remnant of an ancient collision in another solar system. But with no tail, no emissions, and only a brief window of observation, the truth stayed maddeningly out of reach. Oumuamua was, in many ways, the first whisper from the wider galaxy, an introduction that came with no subtitles. By the time scientists realized what it was already leaving, too faint to study in detail. We couldn't measure its composition, couldn't photograph its surface, and couldn't even agree on what it was made of. Some thought it was rocky. Others believed it was icy, but coated in an insulating crust that prevented it from forming a visible tail. Its acceleration as it departed added yet another mystery. It seemed to be moving slightly faster than gravity alone could explain, suggesting some kind of outgassing, even though no gas was detected. And then, just as the debates about Oumuamua began to cool, Borisov arrived. Compared to its cryptic predecessor, Borisov was a revelation. This time, the interstellar visitor didn't play hard to get. It had all the classic comet hallmarks, a glowing coma, a dust tail, and clear signs of outgassing. It was as if the universe had realized the first act was too ambiguous and decided to clarify things with a sequel. Borisov said, in its icy, silent way, "See? Interstellar visitors exist, and yes, they can look just like the ones you're used to." The contrast between the two could not have been sharper. Oumuamua was small, perhaps 100 meters long, and didn't release any detectable material. Borisov, by comparison, was larger and visibly active. Scientists could actually see it shedding gas and dust. With Oumuamua, astronomers had to infer its properties indirectly, reading faint shifts in brightness and gravity. With Borisov, they could collect actual spectral data, measure composition, and confirm what it was made of. It was the difference between finding a blurry photograph and holding the real artifact in your hands. More importantly, Borisov helped legitimize Oumuamua's existence as part of a larger phenomenon. Before Oumuamua, interstellar objects were theoretical, hypothesized but never observed. Its detection in 2017 was met with excitement but also skepticism. Maybe it was a fluke. Maybe it was a misclassified asteroid. But when Borisov appeared just 2 years later, the odds of coincidence evaporated. 2 interstellar objects in such quick succession meant they weren't rare. They were just hard to spot. The galaxy, it turned out, was full of wandering debris from countless star systems, drifting between suns like cosmic litter. Where Oumuamua left scientists guessing, Borisov offered confirmation. Its unmistakable cometary behavior proved that material ejected from other stars behaves just like the material ejected from ours. That alone was groundbreaking. It meant planetary systems across the galaxy are producing comets, lots of them. And some of those comets inevitably get flung into interstellar space. Every star, it seems, contributes to this invisible galactic trade network of dust, ice, and rock. Borisov made it clear that our solar system isn't an isolated workshop. It's one stall in a sprawling cosmic marketplace. And yet, the 2 visitors together told an even more profound story about diversity. Oumuamua was the minimalist, stripped-down traveler, a silent, possibly rocky wanderer, shaped by collisions or stellar radiation. Borisov was its opposite. Exuberant, icy, and flamboyant, wearing a long, shining tail for all to see. They were 2 extremes on the spectrum of what interstellar visitors can be. Between them lies a universe of possibilities, icy fragments, metallic shards, rocky splinters, all moving through the void, each carrying the signature of its home system. Their juxtaposition also taught astronomers something vital about observation itself. Oumuamua showed that we could easily miss such objects if we weren't looking carefully enough. Borisov proved what's possible when we catch one early. As new, more sensitive telescopes come online, like the Vera C. Rubin Observatory, scientists expect to detect dozens more interstellar wanderers in the coming decades. Each will bring a new data point, a new clue about the variety of planetary systems scattered across the galaxy. But beyond the science, there's a strange poetry in the way these two visitors arrived. First, a silent mystery, then a dazzling comet. It's as if the cosmos were telling a story in two acts, the first to spark our curiosity, the second to reward it. Oumuamua made us look up and wonder. Borisov made us understand. Together, they transformed a question, do interstellar objects exist, into an answer written in light and ice. By the time Borisov faded into the black, it had done more than confirm the existence of interstellar travelers. It had given Oumuamua context, proving that our galaxy is not a static painting, but a living, breathing system of exchange. Stars trade dust, planets scatter debris, and every so often, one of those pieces crosses our path and reminds us that the Milky Way is alive with motion. Oumuamua was the mysterious stranger who knocked once and vanished. Borisov was the guest who stayed long enough to talk. Together, they made it clear that we're part of a much larger, dynamic neighborhood. One where stars are constantly swapping stories, one comet at a time. Studying Borisov helps scientists test whether planetary systems elsewhere are built from the same ingredients as ours. Turns out, the building blocks of planets, and possibly life, might be sprinkled all over the galaxy. So, maybe we're not that special. We're just one flavor in a cosmic ice cream parlor. The word alien usually conjures up little green beings with oversized heads and questionable fashion sense. But in science, alien simply means something not from here. And, in that sense, Borisov was the real deal. A true alien. But made of ice and dust rather than flesh and bone. It didn't arrive in a flying saucer or broadcast mysterious radio signals. Its message came coded in chemistry, carried by frozen molecules that had drifted through space for billions of years. When scientists first began to analyze what Borisov was made of, they realized they were holding a mirror up to the galaxy itself. This was our first hands-on sample, well, eyes-on sample, of material that formed around another star. Until then, almost everything we knew about other planetary systems came from telescopic observations of distant planets and disks of gas. We could see exoplanets silhouetted against their stars, measure their sizes, even estimate their atmospheres. But we'd never physically observed material from one of those systems up close. Borisov changed that. It was like the difference between seeing a photograph of a cake and actually tasting the crumbs. What made Borisov so important wasn't just that it was foreign. It was that it was familiar in its alienness. Its composition, structure, and behavior all echoed the same processes that shaped our own solar system. The frozen water, carbon monoxide, and organic molecules inside it told us that the same fundamental ingredients are available everywhere. The galaxy, it seems, follows the same cookbook. The chemistry that makes stars, planets, and maybe even living things isn't a local specialty. It's a universal dish. That realization touches something profound about our place in the universe. For centuries, humanity has wrestled with the question of whether we're unique. Philosophers, theologians, and scientists alike have looked at the night sky and wondered if the same forces that built Earth could be at work elsewhere. Borisov was an icy whisper of an answer. It told us, wordlessly, that we're not alone in the recipe of creation. The same atoms that form oceans and clouds here were also swirling around other suns, freezing into comets and being hurled into the void. But this isn't just comforting. It's also revealing. If comets like Borisov are common, then interstellar space must be teeming with them. Rogue fragments of long-forgotten systems, drifting between stars like pollen on the wind. And if they're everywhere, then every star system, ours included, has probably been seeded by the debris of others. This constant exchange blurs the lines of cosmic ownership. Material from one system may then end up in another, enriching it with new elements and molecules. It's a galactic version of cross-pollination, where the seeds of planets and perhaps life itself are scattered far and wide. That idea isn't just poetic, it's scientific. There's a hypothesis called panspermia, which suggests that the building blocks of life, or even microbial life itself, might travel between worlds aboard comets and asteroids. It's a bold idea, one that blurs the boundary between biology and astronomy. Borisov didn't bring life, but it carried the kinds of molecules life needs: water, carbon, nitrogen, and complex organics. If the same materials are flying between stars all the time, then the ingredients for life are not limited to one corner of the galaxy. They're universal. That universality also reshapes how we think about planetary formation. Before interstellar visitors like Borisov, scientists could only theorize about how other systems build comets and planets. We assumed they followed similar rules, but we couldn't be sure. Borisov provided direct evidence that other solar systems mix the same chemical paints on their cosmic palettes. It's as if every star, no matter how distant, is participating in the same grand experiment: how to turn dust and gas into worlds. What's even more humbling is the possibility that our own solar system has sent out its own Borisovs. Comets ejected billions of years ago, now wandering through the galaxy. Somewhere out there, an alien astronomer might be studying one of our frozen travelers, marveling at its chemistry and wondering what kind of star it came from. Maybe they'd call it something poetic, like the visitor from the blue sun. We might never know, but it's comforting to imagine that the exchange goes both ways. The galaxy isn't a set of isolated solar systems. It's a vast network of travelers, each one carrying traces of home. Borisov also reminded scientists that sometimes the best discoveries aren't about novelty. They're about connection. When astronomers examined its chemical fingerprint and saw those familiar molecules, they didn't just find proof of similarity. They found belonging. The physics that govern distant stars govern us too. The chemistry that builds alien worlds is the same chemistry that built ours. We're not an exception in the cosmic story. We're a continuation. Still, there's something beautifully ironic about how this knowledge reached us. We've spent decades searching for extraterrestrial signals, listening for intelligent life. And yet, the most profound alien message came not through radio waves, but through ice. Borisov didn't send a transmission. It simply was one. Its orbit, its tail, its molecular makeup, all encoded a story about where it came from and what it meant. A message not written in words, but in water vapor and carbon dust. The takeaway? The universe is far less exotic and far more familiar than we often imagine. The same ingredients that built Borisov, that built us, are scattered everywhere like stardust confetti. In a way, that makes life feel both less unique and more miraculous. We're not the only recipe, but somehow this one, ours, baked up consciousness capable of looking back and wondering. So maybe being alien isn't about being different at all. Maybe it's about being part of a vast, shared heritage, an interstellar family bound not by biology, but by chemistry. Borisov didn't arrive to show us how strange the universe can be. It came to show us how familiar it already is. And that realization, quiet, humbling, and cosmic, may be the most alien thing of all. Since nobody could fly to Borisov, astronomers had to study its reflected sunlight. Every color in the light told a story about molecules, temperatures, and history. It's like reading an autobiography written in rainbows, where every hue is a clue to an alien origin. If you think about it, astronomy is the ultimate act of long-distance investigation. You can't touch what you study. You can't scoop up a sample, smell it, or send a probe, not when your subject is tens of millions of kilometers away and moving at 170,000 kilometers per hour. All you get is light, faint, ancient, and elusive. Yet within that light lies everything you need to know, if you can just learn how to read it. That's what astronomers did with Borisov. They became cosmic detectives, using photons instead of fingerprints. Every bit of sunlight that bounced off the comet's surface carried information about what it was made of. The trick was to decode it. That's where spectroscopy comes in. The same tool that tells you what's in a distant star, a planet's atmosphere, or even the glass of a faraway galaxy. It works on a simple but powerful principle. Every element and molecule interacts with light in its own unique way, absorbing or emitting specific wavelengths. Those wavelengths show up as bright or dark lines when the light is split by a prism or diffraction grating, like a barcode written by atoms. When scientists pointed their spectrographs at Borisov, they weren't just taking pretty pictures. They were collecting coded messages from another solar system. The light wasn't smooth, it was lined with dips and peaks, tiny clues left by the molecules in its coma. Each dip corresponded to a chemical fingerprint. Water vapor leaves one pattern, cyanide another, carbon monoxide another still. Piece by piece, those spectral signatures built up a profile of Borisov's composition, temperature, and even how fast its gases were moving. One of the most striking discoveries from those observations was the abundance of carbon monoxide. That molecule, which is rare in the inner regions of our solar system, showed up strongly in Borisov's spectrum. Its lines glowed vividly in the infrared, revealing that the comet was rich in volatile ices, substances that vaporize easily at low temperatures. This matched the theory that Borisov had formed in a much colder region than most comets here. The spectrum wasn't just confirming chemistry. It was painting a picture of climate. hinting at a place so distant from its sun that even carbon monoxide could freeze solid. Spectroscopy didn't stop there. By looking at the widths and shifts of spectral lines, astronomers could measure motion. The lines weren't perfectly still. They were stretched and squeezed ever so slightly. This Doppler effect told scientists how fast Borisov's gases were expanding from its nucleus. Some parts of its coma were moving toward us, others away, depending on the comet's rotation and the way sunlight hit its surface. From that, they could infer not just the comet's velocity, but also its orientation and spin. In essence, they were watching it twirl in space, guided only by the rhythm of its light. Another set of clues came from polarization, the way light waves twist and align after reflecting off dust grains. Different sizes and compositions of dust scatter light differently. By measuring how polarized Borisov's reflected sunlight was, astronomers could deduce the texture of its particles, whether they were smooth or rough, large or fine, icy or carbon-rich. The results showed that Borisov's dust grains were unusually fine, smaller and more uniform than those from most solar system comets. It was like discovering that a loaf of bread from another bakery used a different kind of flour, but the same basic recipe. For all its complexity, the science of light is rooted in something profoundly human, the urge to read. The entire universe is a library of light, and astronomers are the librarians, translating its languages. With Borisov, that meant turning a stream of photons into a story billions of years old. Each observation added a new sentence, each spectral line another word. By the time it was done, scientists had constructed a biography of a traveler that no one would ever touch. But there's also an art to this detective work, a blend of intuition and precision. Light isn't always cooperative. It gets muddled by Earth's atmosphere, absorbed by water vapor and oxygen before it even reaches the telescopes. Astronomers had to subtract those effects carefully, cleaning up the signal until only Borisov's own light remained. They also had to contend with its faintness. As the comet sped away, it grew dimmer, its light spread thin across space. Capturing usable spectra was like trying to record a whisper in a hurricane. Some observatories had to take exposures lasting hours, stacking the results to reveal the faintest features. The payoff was worth it. Those rainbow fingerprints allowed scientists to compare Borisov directly with comets from our own system. The similarities confirmed that the same chemical processes shape comets everywhere, but the differences hinted at the diversity of planetary systems across the galaxy. It was a small but profound connection. Light from another world's debris, passing through our skies, revealing that our corner of the cosmos isn't unique. It's part of a larger pattern. There's also a kind of quiet poetry in the way light connects everything. The photons bouncing off Borisov were, in all likelihood, born in the heart of our sun 8 minutes earlier, forged in nuclear reactions 4.5 billion years after Borisov's birth. Those same photons traveled millions of kilometers, hit an alien comet, and then bounced back into our telescopes, carrying a story across both space and time. When astronomers looked at them, they weren't just seeing Borisov as it was. They were witnessing a moment of cosmic intersection. Two star systems touching for the briefest instant through light. In the end, Borisov's legacy wasn't carried in its tail or its speed, but in the light it reflected. Through that light, we learned what its ice was made of, how its dust scattered, how its gases flowed. More than that, we learned that understanding doesn't always require proximity. It just requires patience and the ability to listen to the faintest signals. The universe doesn't shout. It whispers in the language of light. And so, when Borisov faded into the distance, its photons kept coming, each one a last little message, traveling outward forever. Somewhere, perhaps, they'll reach another civilization with eyes sharp enough and minds curious enough to decode them. And maybe they'll smile, realizing, as we did, that across the cosmos, light is the universal storyteller, and every beam carries a secret waiting to be read. By the time Borisov left the inner solar system, it had changed our understanding of cosmic traffic. It proved interstellar visitors aren't rare flukes, but may pass through more often than we notice. The universe, it turns out, might be full of travelers. Comets, asteroids, and dust grains all hitchhiking between stars. Before Borisov, astronomers imagined our solar system as a relatively quiet neighborhood. Planets orbiting predictably. Comets looping occasionally. Asteroids bumping around in stable belts. It seemed orderly, calm, even isolated. Then Borisov came crashing through that illusion like a cosmic tourist in a rocket-fueled convertible, reminding everyone that the universe is not a cul-de-sac but a bustling intersection of interstellar wanderers. It wasn't a rare miracle. It was a glimpse into an unseen world of constant motion. The data gathered from Borisov's brief visit led scientists to a striking conclusion. Interstellar visitors are probably far more common than we once believed. We'd simply been too nearsighted to notice them. Until recently, our telescopes weren't sensitive enough to spot these faint, fast-moving objects unless they happened to pass unusually close. Borisov wasn't an exception. It was proof that our galaxy is full of cosmic drifters quietly cruising between stars, invisible until they wander into the spotlight. If the galaxy were a vast ocean, our solar system would be just one island, and Borisov was the first driftwood we'd ever seen wash ashore. But the ocean is full of debris. Trillions of comets, asteroids, and icy fragments, all born from the same planetary processes that shaped our sun's family. Every time a young star system forms, gravitational chaos flings material into deep space. Over billions of years, that material spreads through the galaxy like pollen. Some of it eventually drifts into other systems, ours included. Borisov wasn't alone. It was just the first we caught in the act. Statistically, astronomers now estimate that at any given time, there could be thousands of interstellar objects passing through our solar system, most too faint or distant to detect. They range from dust grains the size of sand to mountain-sized chunks of rock and ice. Occasionally, one like Borisov wanders close enough for us to notice, leaving a trail of discovery in its wake. The revelation transforms how we see our cosmic environment. Space isn't a sterile void. It's a galactic highway, full of debris and travelers quietly commuting between stars. That realization has profound implications. If comets like Borisov are common, then every solar system is likely exchanging material with its neighbors all the time. Over billions of years, This constant mingling could mean that no system is entirely self-contained. The elements that built Earth may have come from distant suns. The dust beneath your feet could contain atoms that once orbited another star. The galaxy, in that sense, is one vast ecosystem, endlessly recycling its ingredients. Borisov's legacy also extends into how we search for life elsewhere. If the building blocks of planets and organics can travel freely between star systems, then the seeds of life itself might not be confined to a single birthplace. Every interstellar object that passes through a planetary system could deliver new materials: water, carbon compounds, amino acid precursors. It's not just poetic, it's potentially biological. The universe may have been cross-pollinating itself long before life ever appeared on Earth. But Borisov didn't just change our understanding of frequency. It changed how we look for these wanderers. Before its discovery, telescopes weren't optimized to detect such fast, faint objects. Borisov's surprise appearance lit a fire under the astronomical community to prepare for the next ones. The upcoming Vera C. Rubin Observatory, with its sweeping, wide-field view of the sky, is expected to spot dozens, maybe hundreds, of interstellar visitors over the next decade. Each one will be a new data point, a new chapter in the growing story of cosmic migration. And these future discoveries won't just be passive observations. Scientists are already designing missions to chase or even intercept the next interstellar visitor. The European Space Agency's proposed Comet Interceptor mission, for example, is being built as a kind of standby spacecraft, waiting in orbit for the next wanderer to appear. Once one is detected, the spacecraft could be redirected to meet it, capturing up-close images and data before it disappears back into the dark. Borisov's brief visit taught us to be ready, because these chances don't last long, and the universe doesn't give repeat performances. Beyond technology and telescopes, Borisov's legacy is also philosophical. It reminded us that isolation is an illusion. We tend to think of our solar system as a unique, self-contained creation story, a single, clean origin. But Borisov shattered that narrative. It showed us that cosmic history is shared, that the materials of one world can wander into another's sky. Every atom in the universe has a journey, and Borisov was simply one atom's messenger, gliding through the galactic tide to remind us that connection runs deeper than we think. In a broader sense, Borisov redefined what it means to explore. Humanity has long dreamed of sending ships to the stars, of crossing interstellar space. Borisov, by contrast, came to us. It was proof that interstellar exchange is already happening naturally, all the time, on scales both grand and microscopic. The first interstellar missions of humankind will simply be formalizing what the universe has been doing for eons, trading fragments, swapping chemistry, blending histories. When Borisov finally faded beyond the reach of our instruments, it left behind a changed perspective. It wasn't just a comet, it was a revelation that the galaxy is dynamic and alive, that the story of our solar system is woven into a much larger cosmic narrative. Somewhere, as Borisov continues its journey, it might pass another star, another set of worlds, and its dusty remnants might one day fall into a new sky. Maybe, billions of years from now, another civilization will detect it and wonder where it came from just as we did. In that sense, Borisov's true legacy isn't in the data or the papers written about it. It's in the way it expanded our sense of belonging. We used to think of ourselves as residents of one solar system. Now, we know we're part of a galactic neighborhood filled with travelers, all sharing the same stars and stories. The universe isn't still. It's always moving, always exchanging. And Borisov, that quiet wanderer from another sun, was the one who stopped by long enough to remind us that the cosmos is far more connected and far more alive than we ever imagined. As Borisov faded into the black, scientists waved goodbye to the first true interstellar comet ever seen. Somewhere out there, it continues its endless voyage between stars, carrying the story of its home system frozen in its icy heart. Maybe one day, our probes will do the same, tiny messengers of humanity drifting into alien skies. Until then, Borisov remains our first cosmic postcard that reads, "Greetings from beyond the stars." Every story about exploration ends with a farewell, and Borisov's departure was no different. It came quietly, almost imperceptibly. The comet that had once glowed so vividly in our telescopes began to dim, its tail thinning into transparency, its coma fading until only the faintest smudge of light remained. By early 2020, even the most powerful observatories could barely track it. The first interstellar comet was leaving, returning to the deep silence from which it came. It was like watching a ship's lantern vanish over the horizon, knowing it would never sail back. But there's something beautiful about that kind of goodbye. Borisov wasn't just a visitor. It was a messenger, a traveler from an unknown sun that had crossed unimaginable distances to pass through our sky. And as it slipped away into the darkness, humanity found itself doing something strange, feeling connected to a lump of ice and rock we would never see again. It's not every day that a frozen fragment of another star system wanders close enough to say hello. Astronomers tracked Borisov's final movements with the same dedication they had shown since its arrival. As it left the inner solar system, it carried with it the momentum of billions of years. Nothing could slow it. Not the sun's pull, not the gravity of planets, not even time as we experience it. Its hyperbolic trajectory would carry it forever outward, deeper into the galaxy, until the sun became just another distant spark behind it. It wasn't bound to anything now. It was free in the purest, loneliest sense of the word. That idea, freedom without destination, is haunting. Borisov doesn't orbit. It wanders. It doesn't belong to any system. It simply passes through them. Its journey could last for eternity, gliding through regions of space where light from nearby stars barely touches. It will spend eons drifting between the glowing lanes of the Milky Way, untouched, unseen, unchanging. Somewhere, far from our sun's faint glow, its icy surface will refreeze, sealing away every trace of its brief visit to our skies. And yet, that brief visit left fingerprints everywhere. The data, the images, the papers, it all remains. Borisov gave scientists a legacy that will outlast its light. Decades from now, researchers will still be analyzing its spectra, comparing its chemistry to that of new discoveries, building upon what it taught us. In that sense, it's still here, still teaching, still whispering from across the void. Its body may be gone, but its story is eternal, written not in ink, but in photons and memory. There's also a poetic symmetry to its journey. Somewhere in the cold outer reaches of our own solar system, countless comets are waiting, frozen relics in the Oort cloud, perched on the edge of interstellar space. One day, one of them will be nudged loose by gravity, just as Borisov once was in its home system. It will drift outward, past Neptune, past the reach of our sun, until it too escapes. Perhaps in a few million years, it will cross another star's domain, where another civilization might look up and name it after one of their sky watchers. In that moment, we'll have traded places. Our comet will become their Borisov, a visitor from beyond, carrying the story of our solar system in its icy core. It's hard not to think of Borisov as a kind of mirror, an icy reflection of what we might someday become. Humanity has already sent its own emissaries into the stars. Voyager 1 and 2, Pioneer 10 and 11, and New Horizons, each carrying a record of who we are. The Voyager probes even carry golden records, etched with sounds and images of Earth, our own cosmic postcards, adrift in the endless dark. One day, they too will pass beyond the sun's influence and wander through the galaxy, perhaps for longer than humanity itself exists. In that way, Borisov's journey feels prophetic. It reminds us that the urge to explore isn't just ours, it's universal. Nature itself sends explorers, flinging comets across light years to carry the chemistry of their birthplaces to distant stars. We are simply continuing that tradition, adding our own messages to the galactic conversation. Borisov might have been the first interstellar comet we've seen, but it won't be the last. And maybe, just maybe, one day our descendants will follow in its path, not as passengers on ice, but as travelers by choice. There's something deeply humbling in knowing that Borisov will outlast us. Long after our cities have crumbled and our telescopes have gone dark, it will still be moving, crossing interstellar distances with silent persistence. If you were to watch its journey from afar, you wouldn't see anything dramatic. No grand explosion, no glowing trail. Just a tiny mote of dust gliding through infinity, indifferent to time. But contained within that mote is a record of a star's birth, a frozen fingerprint of a world that no longer exists. Every civilization, if it looks long enough at the sky, will have its Borisov, a visitor that arrives unannounced, leaves too soon, and changes everything in its wake. These wanderers are the universe's storytellers. They carry messages not in words, but in elements and trajectories, telling whoever will listen that the galaxy is alive, dynamic, and connected in ways we're only beginning to understand. When Borisov's light finally faded from our telescopes, there was no grand finale, no explosion or farewell flare, just silence. But that silence spoke volumes. It reminded us that the cosmos doesn't need to be loud to be profound. Sometimes, the greatest wonders pass through quietly, leaving us changed simply because we were paying attention. So now, Borisov is gone. Another faint traveler swallowed by the dark. But somewhere out there, between the stars, it keeps going. Past the invisible borders of our sun's influence, beyond the reach of our instruments, through the interstellar night, a frozen messenger still carrying its story, of where it came from, what it saw, and the brief moment when it crossed paths with a civilization that finally noticed. And maybe that's the most enduring part of its legacy, not its data or its dust, but the feeling it left behind. A reminder that in a universe so vast, sometimes a stranger's visit is all it takes to make us feel a little less alone. Goodbye, Borisov, the first true interstellar comet, the silent traveler who came from the stars and left us looking up, wondering who might pass by next.